Okay, so this question is from 2014 and it is question B2, axonometric projection. Okay, so I pick a dot in the middle of my sheet and I'm marking off a couple of angles. So I'm marking off an angle of 110 degrees and one on the other side 110 degrees because that's what the question asks. I'm trying to find my axonometric plane. Okay. No, I'm incorrect. One side is only 110 degrees. The one to the left is 110 degrees. And I marked it off. Okay. Now, you're told then to measure 50 across the bottom. So I'm going to fit in a base of 50 mil. And then you're told to measure another 40. Then that finds the other angle that you're looking for, out to the other side. Now, using your sliding set squares, put one like so, flip the set square, slide it up to the top, finds one side of the triangle, join this down to here, finds the other side of the triangle. So that's your axonometric plane. Next thing to do is set up the two elevations. So we're finished with this work for a while now. So I'll set up the elevation to the right hand side. So using this as my angle, this line here, I'm going to bring out this point of the triangle or the plane and the top point also. Flip it. I need to bisect that line in half to find the position for my semicircle. There's a semicircle like this, and now I can draw a line like so, and a vertical line also. Now I'm ready to set up the basketball net in this view. So we're not told the value for h, that's okay, and we have to work out what width it is. So from what I can see in the question, point B is bang in the middle. So here's point B. And as B comes out, that is the middle position now for the basketball net. So I take that line up here. Okay. Just like so. Now, you're told now that it's a height of 10 and then a height of 40. So I'm going to measure up 10 mil height, and I'm going to measure up a 40 mil height. And we have to fit a square, that's where the backboard is on the net, so I'm going to fit a square, which has an edge length of 40. So I can go 20 to the left and 20 to the right. Same up here, 20 to the left, 20 to the right. And there's the square found. This is also 20 to the left, 20 to the right across the bottom. That's the bottom of the board. And then the angle is found by measuring up 10 mil. Go out this side, like so. And now it's equidistant out the other side because the thing is symmetrical. So I can take this distance from here to here. I can swing it out the other side. Okay. Now, you're then told to measure up 40 mil, which I've already done. Just like so. So there's a line coming across here. And that line goes straight up like this. I have to fit an arc in around here. Okay? To fit some sort of circle around here. And the center is swung from here. So I just put my point of my compass here, put the pencil there, and I can draw the arc right around to the top of this. Okay, that's the net set up there, and now I need to set up the other elevation, the other side. So I go this way, this view, drop these points, flip my set squares. Again, the position of that line doesn't matter, where you keep this line doesn't matter. Use my compass, bisect this in half to draw my semicircle, so it's the very same as the other side. find the center line, draw my semicircle. Now, semicircle found, bring out O like what I did this side, bring out O out here, and that finds my 90-degree angle. Now out here I just have to measure up 10, 40, and this value H. So 10, 40, and then this is the height for H. From here to the top of that circle is the value for H. That's the height I apply here. Okay, now we're ready to start finding the 3D. So I would make a 3D sketch of the net first. There's no depth or thickness, which is good news, so it'll be very fast find. Now, so I'm going to label it 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Label the same. 1, 2, 3, 6, 4, 5, 7, 8, 9, 10. Apply these dimensions over here. This will be 1 and 2. This dot here will be 6, 9, 10, and 3. This dot here will be 5, 7, 8, 4. And this dot here is the highest point. I'm going to call the highest point O. O, O. Okay, so we'll find them. I'm going to speed through this now. So to find these is the very same way as we'll always find them. If I want to find 1 and 2, bring 1 and 2 back at this angle. Bring 1 and 2 from this angle on this side. So there is 2, and there is 1. It's 1 and 2 found. That's a heavy line. Okay, 6 next. So bring down these dots, which will help us find a lot of the backboard in one go. We can bring down 3. We can bring down 10, because that's on it. We can bring down 9, because that's on it. And we can bring down 6, because that's on it. Chain them up. 6. This one goes to 3. And then we have bottom of the square. There is 9 and 10. Bring down all the other dots then for 5, 7, 8 and 10, or 8 and 4. So bring them down. Bring these down at the same angle again. There is 5, 7, 8, 4. Turn those up. Okay, and that finds a square in the middle board also. Now to get the curve across the top, pick a few random points. So we'll call this 11, 12. We already have O, 13, 14. Apply their heights or get their heights. So there's the height of 11. How does that stand out? There's the height of 11. There is the height of 12. That is the height of 13. That is the height of 14. Take those heights, apply them over here. So if I want to find 14, I take the height of 14. I apply that height over here. That has found 14 on this side. I bring 14 now down at this angle, just like we brought the rest of them. And then bring 14 out to meet it. That there is point 14 on the curve. Do the same with 13. Get the height of 13. Apply that height over here. There is 13. Bring down 13 at this angle. Bring 13 out to meet it. There's point 13. 12 is the same height in my case. 11 was the same height as 14. And I can also find O, or the highest point, so I'll bring it out as well for accuracy. Bring out O. Bring down O. 2 them intersect. Point O. Join them dots up freehand to get to the top of your backboard. Now, the part C of this question says something got to do with a basketball. You're told that a basketball is located at point P. Point P is located in the center of the square. So, point P, let me get a different color. Point P is located in the middle of the square. Okay? Find the middle of the backboard here, just join the 7 corners. So if I join them together, 8 down to 9, 7 down to 10, that finds the position of point P, which is here on this drawing. Okay? And you're told in the question that draw the axonometric projection of a basketball which is in contact with the board at point P and the radius of the ball is 12. So if I set my compass to 12 mil and I draw a radius 12 circle here at point P, that is the basketball. Now, a lot of time students get confused with spheres with regards to trying to find them in axonometric. Just think about it. If you're at the soccer pitch or a GAA match, no matter what way you look at a sphere or a circle or a football, they always appear as circles. They just look like circles. So all I have to do is take that radius 12 and I have to just draw that radius 12 here around point P. That's it. They're just trying to trick you with a very simple question. They're just trying to catch you out. So, that's the answer. Draw a little note on it. Basketball. And that's it. Okay, full marks. Thank you.